My name is SYAFIAH, metric number BT2330317. I will present part 1. On this slide, we have two tables side by side. Both tables analyze data distribution using two metrics: relative frequency, the percentage of data point in each category relative to the total; cumulative relative frequency, the running total of relative frequency summing up to 100. The table on the left focuses on production cost, and this table on the right focus on profit margin. The categories represent cost range such as 10 to 20, 20 to 30, and so on. The frequency column indicates the number of the point. The relative frequency converts these into percentages. Here, 23.3% of the data fall in the 20 to 30 category, while the other range like 10 to 20, 30 to 40 have 10% each. The cumulative relative frequency adds up this percentage as we move down the table, eventually reaching 100. This indicates that all data points are accounted for by the last range. Moving to the right table, we analyze profit margin using the same metric. The significant difference compared to the production cost table. Frequency column showed that 23 out of 30 data points are concentrated in the 20 to 30 range, represent a massive 26.67% of the total in the relative column. The other categories have either very few or no interest at all. Consequently, the cumulative relative frequency reached 100 after just first few range. Now, as you can see on the graph, the x-axis represents value range for both production cost and profit margin, and the y-axis shows the cumulative relative frequency, and the y-axis shows the cumulative relative frequency. For production cost, start at 10% and climb sharply up to 100 by categories 30 up to 40. This indicates the most of the production costs are concentrated in lower categories, reaching the maximum by 40 up to 50. For the profit margin, start similarly at 10% but climb more gradually. By 50 up to 60, it reaches 76.67%, and 80 up to 90, it is at 93.33%. Finally, it reaches 100 in the highest category. Production costs are front-loaded, which is costs accumulate quickly in lower range such as tire control or optimization. And for profit margin, accumulate gradually. This may imply variability in profit margin across categories, or that higher margin are found in later range. So for this graph, if you can see on the production cost line, there are dramatic peak in the 20 up to 30 category, where relative frequency hit approximately 80%. This indicates that the majority of production costs are concentrated in this range. After this peak, the value dropped sharply, approaching zero in subsequent category. This suggests that higher production costs are right. For profit margin, the light blue line is relatively flat, hovering around 10% or less across all categories. There is no single category where profit margin dominated. This distribution indicates a consistent spread of profit margin across different ranges without a pronounced spike.
Good evening, everyone. My name is SYAFIAH EKAMBARAM. My matrix number is BB2330398. In this part, I'm going to explain central location between the two key performance indicators, which is the production cost and profit margin. Firstly, you have to arrange the digits in the column according to from the smallest to the biggest scale. As you can see in the table, it is arranged accordingly. In this part, we're going to look at three different things: mean, mode, and median. For firstly, so mean. How do we calculate mean? Firstly, you have to add up every single digit in the column from the smallest to the biggest, and you have to divide it with the value that contains in the column, which is 30. As you can see, it contains 30 digits or 30 columns in the table. So you have to divide with 30 and you will get for the answer for mean. So firstly, for production costs, the answer is 49.47. Meanwhile, for profit margin, you will get 24.72. Moving on to the next part, we have to find median. How to find median? Based on the column or table, we have 30 digits. in both columns of production cost and profit margin. So how to find median? From the 30 digits, we have to divide 2. So we will get 15. So how to find the median? Number or digit from the 15th column need to be added up with the 16th column and divide into 2. You will get the answer for median. So in this column for production cost, the 15th and 16th digit is 43.7, add up with 48.8, and we will divide it into 2. So the answer would be 46.25. That would be answer for the production cost. Meanwhile, profit margin, the 15th and the 16th column digit is 25.2 plus or add up with 25.5, divide into 2. The answer would be 25.35. That would be answer for median for both production cost and profit margin. Last but not the least, we're going to find mode for both production cost and profit margin. So according to the table, we can see the number 36.2 appeared more than 2 times in the column of 11th and 12th. So that would be the mode for this production cost. Meanwhile, for profit margin in the column of 6th and 7th, you can see the number of 21.2 appeared more than 1 time. So that would be the mode for profit margin. That's all from me. Thank you.
Hello everyone, my name is Arfainizam binti Osman, matrix number BB233030596. I will present the part 3, percentile and box plot between the two key performance indicators. In this slide, we'll analyze the distributions of production costs and profit margins using the percentile and quartiles. This helps us understanding the spreads and central tendencies of these key metrics. First, let's look quartile 1. The calculation shows that production cost is 26.45 million and profit margins is 21.88%. Next, the quartile 3, which is the median of production cost, is 46.25 million and profit margins is 25.35%. For the quartile 3, the indicate that production cost is 67.7 million and profit margins is 27.6%. From this, we observe that as the production cost increase, profit margins also tend to rise, indicating a potential correlations between these variables. The calculate percentile provide the benchmark for evaluating both low and high performance. With this percentile, we can now explore how this data can be used for the strategic decision making in cost and profit management. This slide provides a detailed comparison between two key statistics. On the left represent the box plot of production cost and profit margins. The box shows the interquartile range, which spans from first quartile and third quartile. The median indicates within the box and the whiskers extend to the minimum and maximum value. This box plot provides the clear view of the range, spread, and central tendencies of the data. On the right, the detailed summary tables will with the key percentile and range for both metrics. For quartile 1 until quartile 3, I already discussed before. For the minimum, the lowest production cost is 11.8 million and the lowest profit margins is 16.3%. For the maximum, the higher production cost is 97.2 million and profit margin is 31.2%. For IQR interquartile range, the spread of the middle 50% of the data is 41.25 million for the production cost and 5.73% for the profit margin. The wider IQR for profit margins and production costs indicates the greater variable in the production expenses across the different segments. Meanwhile, profit margins remain more consistent as they are reflected in the smaller IQR. The box plot shows no extreme outliers, indicating the stable data across the both metrics. This analysis provides critical benchmark for evaluating business performance and highlight areas to the target for optimizations, such as reducing cost variability while maintaining consistent profit margins. That's all for me. Thank you.
A very good morning to everyone. My name is PARAMESWARAN MAHENDRAN. My metric number is BB2331100 Today I will continue by presenting part 4, that is calculate and compare measure of the dispersion between the two key perform indicators, that is production cost and also profit margin. In this part 4, we have to calculate 5 main points, that is range, mean absolute deviation, variance, standard deviation, and also coefficients of variance. Firstly, we have to calculate the range. The formula for range is maximum value minus its minimum value. So that is first range of production cost in million, that is 97.2 minus with 11.8. So the answer should be 85.40. Second of all, we have to calculate the range for profit margin in percentage, that is 31.2 minus with 16.3. So the answer should be 14.90. Moving to the next, we have to calculate the mean absolute deviation. The formula that I already given in this slide. Before we calculate the MAD, we have to calculate the mean for the both production cost and profit margin. So the mean for production cost is 1484.2 divided by 30. So the answer is 49.47. So this is the mean value for the production cost. Second, the mean for profit margin. So 741.7 divided by 30. So the answer should be 24.72. So this is the mean for profit margin. After we calculate the mean for the both production cost and profit margin, we have to calculate the MAD for production cost and profit margin. So first of all, we have to see every single data on production cost and profit margin and minus with their mean. After that, we total up everything and divide it by 30. So here we go. MAD for production cost, after total up, we got 649.47 divided by 30. So the answer should be 21.65. This is the MAD for production cost. So second, we have to calculate the MAD for profit margin. So the formula also same like production cost. We take every data and then minus with our mean. After that, we total up everything. So the answer is 93.62 divided by 30. So the answer should be 3.12 after round off. This is the MAD for profit margin. So next, we calculate the variance and also standard deviation. For this, the formula that I already given in this slide. So first of all, we calculate the variance. After we get the answer for variance, we square root the answer and we get the standard deviation. So the variance for production cost is 646.10. After that, we square root the answer for standard deviation. So the answer should be 25.42. This is the standard deviation for production cost. So secondly, we have to calculate the variance and also standard deviation for profit margin. So this also same. First of all, we calculate the variance. So the variance for profit margin is 40.46. So after we get the answer, we have to square root the answer, 40.46. So the answer should be 3.8. So this is the standard deviation for profit margin. So lastly, we're moving to the last part, that is coefficient of variance. Is it very easy actually, because the formula is coefficient of variance equals to the standard deviation divided by the mean. So the standard deviation we already calculate in previous slide. So here we go. So coefficients of variation for production cost is the standard deviation 25.47 divided by the mean, that is 49.47. So the answer should be 0.51. This is the coefficient of variation. Secondly, we calculate the coefficient of variance for profit margin. So this also same like number one. We take standard deviation for profit margin, that is 3.08, and then divided with the mean, that is 24.72. So the answer should be 0.15%. So this is the coefficient of variation of profit margin.
My name is KHADIJAH BT MUASTAFFA and my metric number is BB233010708. So in this part I will present about how to calculate and interpret measure of association between the two key performance indicators. So in this part we need to find two things, which is first we need to find the covariance, and then after that we find the correlation coefficient. To find the covariance, with the formula is in the summation symbol in bracket to xi minus x bar, and then we multiply to in bracket yi minus y bar, and then after that we divide by n minus 1, which is the xi is referred to the value of the production cost, and then the x bar is referred to the mean of the production cost, and then yi is referred to the value of the profit margin, and y bar is referred to the mean of the profit margin, and then after that we divide the n-1, which is the n is referred to the total of the company, which is 30, and then after that we can find the second is correlation coefficient. The correlation coefficient, we use the formula is rxy equal to the sxy divided by sx the nxy, which is the sxy is referred to the covariance that we find before, and then we divide to the sx referred to the standard deviation for production cost, and sy is referred to the standard deviation for profit margin. So next, this is the example table that we do before we calculate the covariance. So in this table we need to find the production cost minus the mean of the production cost, and same like the profit margin minus the mean of the profit margin. And then after we got the two value, these two value, we need to multiply the value of the production cost and the profit margin, and then we need to find the value of the one by one from each company. For example, the Malayan Flour Mills Berhad, the production cost is 43.7, and then we minus to the mean of the production cost, which is 43.7 minus to 49.47, and we get the answer is negative 5.77 something. And then next is the profit margin, which is the profit margin is 43.7 minus the mean of the profit margin, and we get the negative 1.42 something. So after we got these two value, we multiply it, the negative 5.77 something and negative 1.42 something, we multiply, and we got the answer is 8.217 and something. And then we do the same thing for the rest of the company, and after that we can easily find the covariance. Okay, next, this is the answer that we find for covariance and correlation coefficient. We got the covariance is 2512.82 divided by the t minus 1, and the final answer for the covariance is 86.65. After we got the covariance, we can easily find the correlation coefficient, which is 86.65 divided by the 25.42 that refer to the standard deviation for production cost, and multiply by the 3.8 that refer to the standard deviation for profit margin. So the final answer for correlation coefficient is 0.9. Okay, so the summary from this part is a correlation of 0.9 indicates a very strong positive relationship between the production cost and the profit margin. It means that as the production increase, profit margins will tend to increase as well, and this can suggest more efficient or higher level of production that are associated with higher profitability. So the implication from this correlation is show that increasing production cost is likely to lead to improve the profit margins and give the supporting strategies to scale production for the better profitability. So that's it from me, and as this is the last part, so that's it from our group. Thank you.